Hello. This video and its associated research has been compiled by myself, Anthony Griffin, and my partner, Will Parker. We have certainly delved deep into cryptography and various algorithms in the continuous race to define a nearly unstoppable encryption algorithm. However, throughout this field's short but complicated history, things have come far too close between those who hack and those who encrypt. If those who act maliciously or unfairly were to win this race, our data in the world's top institutions would be immediately at risk. Take a look at this map that shows the continuous attempts across geographical barriers to take each other's data. This map was loaded on May 10th around 10 a.m., meaning 18 million attacks happen in less than half of a day, so the danger is unmistakably there. Enter quantum computing. Quantum computing is all about applying the physics of our universe into the current binary realm of modern-day computing. But what applications of quantum physics could I be referring to? Certain observable features are inaccessible in the binary format, such as the concept of superposition. Superposition refers to an object's value as uncertain. An example of this law would be if you were to spin a quarter. Is the quarter heads or tails? While it is spinning, the quarter is said to be in superposition, some value in between heads or tails. In the case of binary units, they are passed through some sort of filter to randomly choose either 1 or 0. The actual value cannot be predicted. For another critical concept, take a look at quantum entanglement. Dr. Talia Gershon, senior manager at IBM, explains this concept particularly well to a teenager in high school.
In the quantum world, when we entangle things, they're really now connected. It's much, much harder to separate them again. So using the same analogy, we spin our pennies and eventually they both stop, right? And when they stop, it's either heads or tails, right? So in my case, I got tails and you got heads. You see how they're totally disconnected from each other, right? Our pennies in the real world. Now, if our pennies were entangled and we both spun them together, right? When we stop them, if you measured your penny to be a head, I would measure my penny to be a head. And if you measured your penny to be a tails, I would measure my penny to be a tails. If we measured it at exactly the same time, we would still find that they were both exactly correlated.
That's crazy.
It's so cool, right?
Oh my god.
Now, how do we use these odd bits of data that are now capable of superposition and entanglement? And how does this relate to computing and cryptography? Cryptographic researchers around the world are finding creative ways to remove the problems that have been plaguing the cryptography industry since its inception. For instance, some have tackled the issue of pseudo-random generators, the issue being that these mechanisms do not produce a truly random output. However, Vikram Sharma has crafted a truly random number generator using the qualities of quantum mechanics, which he can be seen showing off here in his TED Talk. But there is considerable danger in applying traditional cryptographic methods, such as RSA, in a world of quantum computing. A big change in quantum computing is the improvement in efficiency, resulting in computations taking a square root of its original time. So figuring out the private key of algorithms using the public key takes very little time. That's why many experts say quantum computing needs quantum cryptography with reinforced algorithms to keep our data secure. New techniques, such as the one you can see here, are purely theoretical, but a few organizations and researchers are proactively securing these techniques from man-in-the-middle attacks. Check out the PBS video linked below to see what man-in-the-middle attacks look like in quantum computing. Now, this is just a brief overview of some incredibly complex and fascinating developments in the field of quantum cryptography. To get a more detailed look at a lot of what I've described, check out the videos linked in the bibliography under the video's description. Thank you for watching.